Okay. Yeah, so we're in probability here. And as I was saying right before class started, so the plan is our exam will be next Thursday, week from today. Exam number 3. We only have 3, then the final. Exam 3 next Thursday, and so Tuesday will be review. So today I'm going to finish up the material. This is the last section that is on next Thursday's exam. Tuesday we'll go over the practice exam right here in class on Tuesday. All right, so 2 dice are rolled, find the indicated probability. We're talking about like the given. What is the probability? The sum of the point totals 5, sum of the points totals 5 if the first die is a 2. So this is given. I was doing that's right, I was talking about the New England Patriots in the Super Bowl, and I was saying, you know, what would the chance they're going to win given the halftime score, or given given means changes probabilities. Talking about insider trading with Martha Stewart, right, and how that's illegal. So probability is all about what you know, right? If you know more information, that changes probabilities, right? So that's what we're talking about in this problem. So look what they're saying. You're going to roll 2 dice. And before I do the whole, I don't want to do the whole big array, you know, because they're telling me what's the chance the total is 5 on the dice if the first die is a 2. See, they're giving me some information. They're saying, hey, you rolled the 2 dice, and I'm saying, hey, guys, my first die was a 2. My first number came up to be a 2. And I'm saying, what's the chance the total of my 2 dice is 5 if my first number is a 2? So in other words, if you think about that big array we made, I'll just do one row, one column of it. You would just do this column that had a 2, 1, 2, 2, 2, 3, because you know the first number is a 2, right? So that's all we need. It's one of those 6 things that happened, huh? Because you know the first number is a 2. So if we're talking about probability, remember what goes on the bottom is the total. So that must be 6. There's 6 different things that could happen, huh? And what goes on the top is the number for whatever you're wanting to happen. We want a total of 5. That would be that one result out of 6. The probability is 1/6. Right? Because 2, 3 totals 5. If you rolled a 2 and then a 3, if the 2 dice came up 2 and then 3, that's a total of 5. And that's what they're saying. Total of 5. The first die is a 2. So there's a 1/6 chance of doing that. Right? So if I rolled 2 dice and said, hey, the first number is a 2, then it's one of those 6 things that just happened. What's the chance the total of my 2 numbers is 5? Well, I'm saying, what's the chance I got a 2, 3? Well, it's 1 out of the 6 things that can happen when you know the first number is a 2. Make sense on that? That's what this section is all about. It's being given some of the information. Is what it's a little different. That's different than if they just said, hey, I rolled 2 dice, what's the chance the total's 5? That'd be, there's more to it than that, right? We did some of those in the last section, right? But when they say you're given the first number's a 2, that limits it. That limits it. All right. Talk about independence and dependence. So right here we're saying we have 2 events, E and F. Are they independent or dependent? Let me write that for you. Independent do not affect the probability of each other. So independent events do not affect the probability of each other. So I think examples are probably more helpful than words almost. What if I said, what's the probability it's going to rain today versus what's the probability that I'm going to roll a 3 on the die? Those have nothing to do with each other, huh? Whether it rains or doesn't rain doesn't make it any more likely or less likely that I'm going to roll a 3 or not roll a 3 on a dice. Weather has nothing to do with dice rolls. Whereas dependent, if I can come over here maybe, dependent events, they do affect probability of each other. So that would mean like, what's the probability it's going to rain today? And what's the probability I'm going to bring an umbrella today? Well, those are related. right? If it's more likely that it's going to rain today, it's also more likely that I'm going to bring an umbrella, for example, right? Or wear a jacket, or those are things that are related to each other. One of them being more likely makes the other more likely, right? Is that good? Is that making sense? So they're going to give us a bunch of things and ask us if they're related like that or not. Okay, so what are the two they're talking about? The question we have, they're saying E is a person going into debt, and F, the same person having a credit card. Do you think there's any relationship between those two? Do you think having a credit card might make you more or less likely to go into debt? Than we all know. In our current age, it's so easy to run up credit card debt, huh? So yeah, having a credit card does make it more easy to go in debt. So those are definitely related. And so that's why I've already answered the question for you. I checked E and F are dependent. They do depend on one another, don't they? Because having a credit card can affect your probability of going into debt. Those are dependent. They're not independent. They're not separate. They relate to one another. It's not a for sure. It doesn't have to be a for sure thing. Obviously, right? A lot of people have credit cards and are not in debt, but it does make it more likely, right? So, and then B says, let's do B now. What are the two events on B? Last question, coloring her hair black, and another person coloring her hair blonde. What's the chance what's the probability that you grab a random person and that person is coloring her hair black? What's the chance you grab another random person coloring her hair blonde? Well, those have nothing to do with each other, right? You're just randomly picking people. The events are independent. One doesn't really affect the other, right? If I said, hey, I randomly picked a person out of the crowd, and it turned out she was coloring her hair black. And somebody says, wow, I randomly picked a person out of the crowd and they were coloring their hair blonde. That must be because when you pick a black, that means that, no, there's no relationship there. That's totally independent, right? Does that make sense on that? All right. And then part C. The war in a major there's a war in a major oil exporting country. And the price of gasoline. Do those things affect each other? Well, yeah, right? If there's trouble in a major oil exporting, those are going to be dependent, aren't they? They're going to affect each other on that.
The answers it gives on that will say E affects F or F affects E.
Yeah, it'll be just like the one up here was. Yeah, it'll have different ones like that. It'll have two dependent answers. You got to read the right words for the right one on that. Yeah.
Scroll down to see what the answers were for the bottom one.
Oh, you're talking about the bottom one?
Yeah.
So they're dependent?
Yeah, I say dependent.
Oh, consumer research, the consumer demand for synthetic diamonds, the amount of research funding for diamond synthesis. Those are going to be related, right? If consumers want more synthetic diamonds, then there's going to be more funding probably for diamond synthesis. Those are going to be dependent events. Does that make sense on that? So do the two things affect each other you want to ask about? It's not like rain and rolling a die. Those have nothing to do with each other. It's more like rain and an umbrella. Those are related, huh? One affects the other on that. All right. All right, so when events are independent, so let me just write that. When A and B are independent. Independent meaning not affecting, they're independent. They're not affecting each other. When they're not affecting each other, then the probability of A overlap B, this means and, overlap means and, is just the probability of A times the probability of B. Let me put a star by that and write the word important. Make sure you put that in your 3x5 card. We're going to use that several times in this, well, maybe 3 or 4 times in this section. So when two events are independent, when they don't affect each other, like rolling the die in rain, you know, they're just totally unrelated. The chance of both of them happening is the two chances multiplied. So let's go through the question then. So when they say the probability of A is 1/7 and B is 1/4, and they're independent, then how did I figure out that the overlap, the and, is 1/28? Because I took 1/7 times 1/4. We got 1/28. Because that's what this is saying. You multiply them when you have and. You multiply them when you have and. Is that good so far? Now, how do we do the union one?
There wouldn't be a union because they're both independent events, right?
So union means like uniting the softball team and the, you know, it means putting them all together.
So you just add them?
So I would make a Venn diagram. Yeah. So we have A and B. And, okay, so what's the, oh, it's going to be a little tricky with these numbers, huh? These are fractions. That's all right, we can do it. All right, so what goes in the very middle? Always start with the middle if you can. Remember how that's always the easiest place to start, is the very middle, the overlap? What goes in the very middle?
128.
That's the 128, that's the overlap, huh? 128 right there. So now, can I get like what's right there in A? How do I know? Well, all of A is 1/7, huh? Does that make sense? All of A is 1/7. So how do I find this little part of A?
Subtract.
Subtract. So I've got to take 1/7 minus 128. Does that make sense? Like taking 1/7 of the pi, take away 1/28 of the pi, see what's left? How do we subtract two fractions? Do you remember? Has it been a little while?
Bring everyone up.
The denominator have to be.
Common denominator, yeah. You got to multiply top and bottom of this one by 4 to make the bottoms the same. So it becomes 4/28 minus 1/28. So the answer is 3/28. Does that make sense on that? So this part here is 3/28. See how that's working? See how those two together now make 4/28, which is 1/7? See how circle A is now 1/7, like it says? Can you find the other B part? Go ahead and try to find what's out there in the B part. Is that what it is? It's going to be, yeah, right. Yeah, so let me do it for you too. But yeah, it is 6/28. So yeah, because B, I can hardly read it now. What does it say here? 1/4. So B is 1/4. So come on down here, I guess. So yeah, because all of B here is supposed to be 1/4, huh? So it's going to be 1/4, take away that 1/28, multiply top and bottom by 7. 7/28 minus 1/28, 6/28. And you can leave it that way. You can reduce it. It doesn't matter. I'm just going to leave it 6/28. Whatever. Good enough. It reduced to be 3/14, but who cares? 6/28. Now, last thing. What are they asking me for? The union. What is the union? It's this plus this, all put together. The union means like everybody all together. Does that make sense? I keep doing the softball things. I don't know. How about just two classes, Class A and Class B, right? What if you know how many? What's another? You guys all have like a business class, or some of you guys have a business class in common. Let's say that this is our class, finite math, and this is some business class, and then you guys, some of you guys are in both, right? That's kind of what this is showing. And so when we say overlap, we're saying how many people are in both classes, one person. And when we say union, we say how many people if the two classes united together. So that would be what? Just add them up, 10, 28. So the union, bring it over here, the union equals 3/28 plus 1/28 plus, was it 6/28, which is 9, 10/28, and we're supposed to reduce it. I'm fine on the test, I give you credit, doesn't matter. 5/14 is what Math Excel is going to want. Reduce that top and bottom by 2. 5/14 must be the union. Is that good? So we united all these together. It just means both groups together. They unite. So this answer is 5/14. All right, so let me recap that problem. There was a lot of work on that problem. So when they say independent events, the overlap is just multiply the two together. Put that in the middle, and then start subtracting and get the whole thing and add them up for the union. Good on that? Questions on that? All right. All right, so Bicycle Factory runs 2 assembly lines, A and B. 95% of line A's products pass inspection, and 92% of line B's products pass inspection. 50% of the factory's bikes come off assembly line B, and the rest come off A. Find the probability that one of the factory's bikes passed inspection and came off assembly line B. Find the probability that one of the factory's bikes passed inspection and came off assembly line B. Okay. Okay, so how are we going to do this one? Basically, when they say the whole key is the and, let's be clear what the question is. Probability that it pass inspection and it's from line B. Whenever they say and, they want you to do the overlap. And, so you want to know that and means the overlap. Union is or, overlap is and. So, they're really saying the probability of this is, and what did we learn just in the last section? We learned that when you have like A and B, that it's just A times B when A and B are independent. Right? When A and B are independent, to figure out the and, you just multiply them together. Okay, so how am I going to do that? Well, what's the probability of, what are the two things we're talking about here? What's past and so I hope I'm being clear. What I'm basically saying is we got to multiply these together. Got to multiply these together. So, first off, what's the probability of passing inspection in line B?
92%.
Yeah, 92% of line B's stuff passes inspection. So this is going to be make it a decimal, 0.92 times, and what's the chance that it comes off line B? 50% come off line B. 0.50. Multiply those together. Is that 0.46? And we got it. Now hold on for a second. Let me make sure that's really sinking in well, because it's going to be kind of subtle on this really gets a lot of people on the next exam. So you got to notice the word and, because it's not going to jump off the page and grab you and slap you around and say you got to do an overlap and multiply them together. It's not that obvious. That's what's tricky about it. It's subtle, isn't it? That word and has to be huge for you. It has to be big. Whenever they say blank probability, whenever they say probability, I mean probability of this and that, you should think, oh, I bet I multiply them together if they're independent, and they are, right? Being passing inspection and being off a certain assembly line are totally independent. So multiply those together. 0.46. So and means multiply together. It's overlap. Let's try this one. All right. So now find the probability the service was good, given that the meal was lunch. All right. Let's first get the hang of that big old table. Do you see what's going on that table? So for lunch, this is at some restaurant. 12 people thought the service was good. 16 thought it was poor. That's not so good, huh? 28 people total. 28 people came into the restaurant for lunch. The majority of them weren't very happy with their service. 16 were unhappy, 12 were happy. For dinner, 19 and 27, 46 total. Again, a lot of them are not very happy with this. Isn't a very happy restaurant. All right, so there we go to there. Is that good so far? And making sense of the table? Now, what's their question? If you were to grab somebody, these are 74 people altogether. If you were to grab one of them at random, find the probability the service was good given. Now remember, there's that word given. That's what this section is all about. Whenever it says given, it's narrowing down what you're talking about. Given that the meal was lunch. So if we're talking about lunch, we're not talking about the whole table anymore. We're just talking about the lunch part of it. So it's just this part, huh? Not this stuff down here. Does that make sense? When we do probability and we're talking about lunch, the bottom is always total, huh? The bottom is always total. The top is always 4. So what's the total? What's the total people that came in for lunch? 28, right? And what's the probability the service was good? If you grab somebody who had lunch there, what's the chance it's going to be somebody that thought the service was good? 12 out of 28. And then you can reduce that, divide top and bottom by what, 4? 3 sevens. Yeah, does that make sense what I did there? Do you see how the given limits the field? That's what given always does. You're given some information. It changes the information. So it limits it. The given limits it. Given it was lunch. Okay, good? All right. There we go. Try that one. Here's the question. Find the probability the service was good given it was dinner. So the bottom always goes to the total. The top goes to 4. So again, the given always tells you the bottom, doesn't it? It tells you the denominator. It limits the field. It limits the total. So what's the total given it was dinner? Yeah, 85. Huh? Is that good? And what's the top? The service was good. So that's 40 out of 85, huh? Then just reduce that. Oh, we can't divide by 4. What am I doing? That doesn't reduce it. Oh, divide by 8, huh? Divide by... No, not 8. By 5. I am the math teacher, but I can't do my times tables. 8 over 17, is that right? 8/17. I don't care if you don't reduce them on the test. It's fine. 8/17. Is that making sense then? So again, the given limits the total, doesn't it? The given limits the total. You're just talking about the dinner people. The table shows frequencies for red-green color blindness in one doctor's practice. M represents a person is male. C represents a person is colorblind. Use this table to find the probability of M. Okay. Yeah, so let's make sure we're making sense out of what that table's even saying first off. So this is all the patients that come into this doctor. Basically, let's see this right here. That is 0.048, in other words, 4.8%, right? 0.048, 4.8% of them are what? Are C and M. That's the intersection of C and M, right? So what is C and M? C is colorblind and M is male. So 0.04, another 4.8% of the patients that come to this doctor are colorblind males. That's what that's saying. 0.048 is the same as 4.8%, right? Okay, what is this 0.008? It's 0.8%, and what is it? M with a little mark. See the little mark there? that means not. Remember those, whatever it's called, the single quote mark, the complement mark. It means not M. They're not male, so they're female. They're females. And they're colorblind. Colorblind females, huh? Colorblind females. And then this 0.459, not colorblind males, right? The C complement. And then this 48.5% are not colorblind females. Okay, and then what's this 0.507? Total number of males, or total percentage of males, 50.7%, just over 50% males. Total number of females. What about over here, 0.056? What's that? Total colorblind, 0.0, right? 5.6% of all patients are colorblind. That one, 94.4% of all patients are not colorblind. All right, let's put it all together now. The table shows so what's the P of M?
Total number of males.
Yeah, so that would be the 0.507, huh? Just like that. We good? So far so good. They're going to get more tricky. Make sure we're reading the tables. Okay, see if you can get that one. So we've got M complement overlap. Remember what that always means? That means and. C complement. So that's this number right here, huh? 0.506. It's M complement, C complement. Both, and. Both them together. Does that make sense? All right, let's keep rolling. Now I need to give you a formula. Okay, so now it says, let me make it a little bigger, probability of M, and then a straight line. What that straight line means is given. That's a shortcut notation for given. It means what's the probability that they're male given that they're not colorblind. That's what that's actually saying. That straight up and down line is the given. It's the condition. It's called a conditional probability. That's what the title of the section is, conditional probability. We're given the following condition. What's the probability you got a male given that you've got somebody not colorblind? So that'd be like saying, hey, I went to the doctor's office. I ran into one of Dr. Jones's patients, right? And by the way, they were not a colorblind person, right? We're given that information. What's the chance it was a male? That's what they're asking. Given that you've got a not colorblind person, what's the chance it was a male?
0.38.
Well, that would be if they said M and C bar, right? The 0.38 would be if they said, what's the probability that it's M and C bar? Because that is the end. That's the number that are colorblind and male.
Did you divide it by the total of males or
By the total of,
0.426?
yeah, no. You're going to divide it. Let me give you the formula, and then it's this. You would divide it by the C complement. Because that's the pool you're taking it out of. Remember the given is the group you're taking it from. You know you've got a not colorblind person. So how many are not colorblind? 0.945. That's the total. So we're saying 0.38 out of 0.945. That's what we want. So 0.38 out of 0.9. Just divide them on your calculator. Somebody got that number? It says round to 3 decimal places. 0.402 rounded to 3 places. That good? Anybody else get the same number? Just have a verification. I don't have my calculator today. That looks right to me. Yeah, I think it's it. Yeah, good. So that makes sense. So let me slow down here because there's where the formula suddenly got a little more tricky. Basically, when you have given, in fact, let me just write the formula up here for extra clarification. Whenever you have, I'll call it the given formula. The given formula. Whenever you have the probability of A given B, it means the probability of A and B over the second one. That's the definition of how you do given straight line. It's the intersection over the second one. It's always the overlap, the and, the intersection over the second one. So that's what we did. I took these two things, I did the intersection over the second one. But I wanted to make sense too, not just be some math formula on a paper. Math always works better when it makes sense. Does that make sense? So look at the not colorblind people. 0.38 are male, 0.565 are female, right? As you look up there, you just take a look with me at the not colorblind group. Now, why am I focusing on that group? Because that's what I'm given. Just like in the other problems, remember, whatever you're given, that limits the pool. Like when I roll the dice, say, hey, I'm given, it's a 2. Or back over here, where was one of the other given ones? Let's look back where we had a given. Yeah, here we go. Given the meal was dinner. So what did I do? I only looked at the dinner, huh? Right? And I took the total for dinner, that was on the bottom. And I took the good dinner, and that was on the top. Well, over here, huh? See that? See how I'm really doing the same thing there? See how I'm taking the intersection of good. Really, they're saying from the probability that it was good given it was dinner. That's what they're saying, right? Probability it was good given it was dinner. So what did I do? Good and dinner, which is the 40, good and dinner over dinner. Right? Does that make sense? Because the given limits the field. So same thing here. When they say given that it's not colorblind, you know you're talking about this colorblind group. So take the total, put that on the bottom, and then you're saying male, so the males, put that on the top. And there we go. That makes sense? That formula make more sense now that it's that way? The intersection over the second one. All right. Let's try. All right. The motor vehicle department has found that the probability of a person passing the test for a driver's license on the first try is 0.78. The probability that an individual who fails on the first test will pass on the second try is 0.86. Find the probability that an individual fails both the first and the second tests. Let me give you a second. I think you get more out of it than if I just flash some formula. These take practice. They're all what's hard about these are all a little different. There's not one size fits all, you know. Give you a hint. That word has to be really big. Remember how I said that's got to jump off the page for you? What does and mean we're going to do?
Overlap.
Multiply two things together, right? It's overlap and it means multiply. It means multiply them together. Multiply what? What two things together? Well, the two probabilities. What if I said, hey, the chance of rain tomorrow is 80%. What's the chance it won't rain? 20. You got to subtract from 100, huh? So they're saying fails. Both. So first and second. Fails first and fails second. What's the chance of failing the first?
78.
The chance of a person passing the test is 0.78. So what's the chance of them failing the first test? Yeah, 1 minus at 0.22. Does that make sense? So fail the first, 1 minus 0.78, 0.22. Good. What's the chance they're going to fail the second?
14%.
Pass the second is 0.86, so 1 minus 0.86, 0.14. That makes sense? So there's a chance fail the first, fail the second. So what's the chance fails first and second? First, fail, well, probably fail first and fail second is going to be 0.22 times 0.14. How you multiply them together? Does that make sense? The and is multiply. And what is that again?
3.1%.
.31?
Well, it's .0308.
0308. Oh, gotcha. Thank you. 0308. Yeah, we're supposed to round to hundredth. It says this is two hundredth. Remember, you know how places go. The first one's the 10th place. Next one's the hundredth place. Then the thousandth place. So if they tell me to round to the hundredths, you circle the place they tell you to, and you look one to the right. If it's 5 or more, you go up. Otherwise, you leave it. So .03. 0.3. There's a 3% chance that somebody will fail the first and the second test. 3%. Say good. Questions on that one? So and is multiply, huh? And is multiply. But this one we had to do the 1 minus 1 minus. It was a little tricky. So they take practice. These just the motor vehicle department has found that the probability of a person passing the test for driver's license first try, probably the person will require at least 2 tries. All right, let you do that. This one's really easy if you'll read the question carefully. This one's like a reading the question exercise. There's hardly any math to do. There's one math step to do, which is very simple, if you read it carefully. This is where I've noticed over the years that really one of the problems in math is actually reading. Because careful reading is not always easy to do. Math kind of requires that. Give you a minute. Ask yourself, what do they want from me? What are they asking? Be super clear on the question. What is it they're asking? Why do you think so?
Well, I just put it in and worked on it.
So why does that work?
I mean, I ended up subtracting 1 minus.
I know what you did, but why'd you do it?
Because you need at least 2 tries to pass, so you're already passing the first time, I guess. I don't know.
Fail the first time.
What's that?
No matter what, I mean, at least 2 tries means they failed the first time no matter what.
Well said. That's the first thing to be really clear on. If I say, hey, when I took the test, I needed at least 2 tries. What does that mean happened the first time? Did I pass? No. Right? That is equivalent to saying I failed the first time. When somebody says, I needed at least 2 tries, right? That means I failed the first time. That's just fancy talk for failed the first time. So they're just saying, blah, blah, blah. What's the chance you're going to fail the first time? Isn't that what they're saying? It's just a fancy, weird way of saying that. See what I mean there? Right? If you need at least 2 tries, that's fail the first time. That's all it's saying and nothing more. It doesn't tell us whether they passed the second time or not. They're not even asking us that. All they're saying is what's the chance they'll need at least 2 tries. That means 2 or more, meaning they didn't pass the first time. They're saying what's the chance they failed the first time? Well, the chance they pass the first time is pass the first is 0.76. So what's the chance they're going to fail the first? That's like there's a 76% chance of rain tomorrow. What's the chance it won't rain? 1 minus, huh? So that's the only actual math operation we do. Does that make sense on that? So you see what's hard about these is they're all a little different, huh? There's not like one, every probability you just multiply them together and add the thing and there's your answer. No, they're all a little different. They're going to throw curveballs at you. You got to be up there kind of thinking. And my little 7th grader is experiencing that in baseball now. Used to be in Little League, it was always a fastball. If you just had the eye for the ball, you could hit it. But now he's in 7th grade, and the pitcher throws a curve sometimes, and my son's like backing out, and it's like, strike. Whoa, I was headed to my head. What happened there? Yeah, curveballs. It's a little different. You got to be ready for different things. That's what it's like for these probability, right? It's not just straight pitch every time. They're going to do weird things. So you got to read the questions and practice. That's Okay, table shows results, restaurant survey. Find the probability meal was dinner, given the service was poor. Yeah, let me let you try that again. Remember, the given limits the field, right? So remember, what's given is always the denominator, right? Given is the denom. Remember that? That's the denom. That's the total in the probability. So what's the denominator going to be?
64.
Good. Is everybody dialing in on that? Because that's the total service poor. That's the total of the service poor, huh? Which is what we're being given. Is that starting to be more comfortable? And then the thing on the top, what are they asking? Dinner. So what would that be? That's the 45. You stay within that column. Once they identify the given, that limits. You're not going anywhere outside that column for sure. Does that make sense on that? And is that reducible? I don't think so. No, that's just it, huh? So that's just it right there. Is that okay? So again, given limits you to just one column or row in the table. Well, the other times we did table, it was a sideways thing. If they had said, if the given was lunch, then I would have just done the sideways lunch row, huh? Or if the given was dinner, the dinner row. But if the given was poor, so it was the vertical poor column, they could have said okay or good, and that would have been those columns on that. Is that good for the given? All right, try that one. Probably the meal was lunch, given the service was okay. You define this. So the given limits us. So circle the row or column for the given. Okay, so it's that, huh? So there's where we're at. So the probability is the 79 is going to be the denominator. And they said lunch, so that would be the 34, huh? There we go. Is that good? Getting more and more comfortable? Questions I can answer? There we go. Okay. Try that one. So always focus on the given, right? That limits our field. So what's given? The customer did not make a deposit. They did not make a deposit. So where's that? That's this row, huh? The no deposit row. And so the denominator is the 30. And then what are we talking about? Did not cash a check. No check would be the 12. 12 out of 30? Then reduce it, huh? Is that good? Getting easy. Divided by 6, be 2/5 on that one. All right, getting the hang of this conditions and give. All right, try that one. Find the probability that a customer did not make some other transaction. Give the customer cash to check. The other refers to the word other in the table, I think. All right, this was a little funny. So, first off, what's the given? It's all about the given, huh? The customer cashed a check. So what limiting does that do? Is it a column, an up and down, or a row sideways? It's here, isn't it? Customer cashed a check, right? We good there? So the given always limits you, right? We're not even going to consider anything else on the table. The given always limits us. Okay, so we know the denominator, right? 71, that's good. Now it's all about the numerator. That's a little tricky. They say, did not do the other. So they didn't do the other. So you got to add up the 18 and the 23. It's both those. Does that make sense? It's not the other. That's a little weird. It's not the other. What's that? Is that 41? Over 71. It's a little different. It's because they said not other. So usually they just pick one spot, huh? But there they said not one of the spots. So we add the other two up. 41 out of 70. All right, number 19. The probability that the first record of a singing group will be a hit is 0.2. If their first record is a hit, so are all their subsequent records. If their first record is not a hit, the probability that their second and all subsequent ones being a hit is lower, 0.1. If the first two records are not hits, probably that the third is a hit is even lower. Find the probability that a group has exactly one hit in their first three records. So let you read. It's all about reading. The answer's kind of just there if you read careful. This one's a little tricky. So what are they asking? They're asking the probability exactly one hit. There's a couple of logical steps to walk through. First off, how do they, could their first one be a hit and then the other two are not? When they say exactly one hit, they mean one, not two, not three, not any other number, right? So exactly one hit, that's the point of the exactly, right? Not one or more, in other words. That'd be a different question, right? They're saying, what's the chance that out of their first three records, only and exactly one of those three is a hit? Well, think with me, according to the words, could the first record be a hit and the other two not? Let's read that first sentence again carefully. The probability that, second sentence. If their first record is a hit, so are all their subsequent records. So no. See, if the first was a hit, the second and third would be as well. That would not be exactly one hit. So that can't be what they're asking for. It's not, the first one can't be the hit. You with me on that? Could the second one be the hit? No, same problem, right? If their first is not, the second and all subsequent. So basically, once you get a hit, all the rest are hits after that, is what they're saying in those words. You catching that? So when they say only one hit, they mean the third one's a hit. That's really what they're asking. Everybody see how I've arrived at that conclusion first off? Right? They're basically saying, once you hit a hit, after that, all the subsequent, all the ones after are hits. So if you only want one hit out of three, it's got to be the third one. It can't be the first or the second. That's all in the words, right? It's all careful reading of those words. I really think math is a great thing to make you a more careful reader. Well, studies have shown, not my opinion, studies have shown that math, do math word problems particularly, not numbers, but math word problems make you a more precise reader. It's one of the best things to make you a more careful reader. Anyway, so they're talking about the third one being a hit. Third one being a hit. Okay, so what's the chance the third one's a hit? Well, can I just say 0.05? Almost. That's the chance the third one's a hit, yes, but that's if the first two are not hits. So I can't just say that alone. In other words, what they're really asking, so that's after all that talk, I hope that makes sense. They're really asking, what's the probability? The first is a no, and what's that mean I'm going to do? Multiply. The second is no, and the third is a yes. That's really what they're saying. To see that? They're saying, what's the first is not a hit, the second is not a hit, and the third is a hit. That would be the only way you could have exactly one hit in the first three, right? Because it couldn't have been the first two, because once you hit a hit, all the ones after that are hits as well. So, okay, what's the chance that the first is a no? Well, the first is a hit is 0.2. So what's the chance the first is not a hit? 0.8, right? 1 minus 0.2. First no or not a hit is 0.8, right? Because the chance of rain, the chance it's a hit, is 20%. What's the chance it's not a hit? What's the chance it's not going to rain? 80%. That making sense? And the second one, and so that's going to be multiplied in a minute. What's the chance the second is not a hit? First is not, second is not. What do you look down here? The chance the second is 0.1, so not the second is 1 minus 0.1. 0.9? You good with that? 0.9 is the chance the second is not a hit. And the third is yes, that's 0.05. We got to multiply those together. Is it 0.036?
Yep.
0.036. Did that make sense how I tracked through that? That's kind of hard, huh? That requires some careful reading and thinking. Let me make sure I'm right. Let's see. Let's look more carefully. Probably that their first record, the single group will be hit is 0.2. Second record is a hit, and so are all subsequent records. If their second, right, if their first record is, yeah. If, let me erase this right so I can read it. If their first record is not a hit, probably that their second and all subsequents is 0.1. But the first is not, is 0.89, and the second is not, is 0.9. And yeah, that looks good to me. The first two records are not hits. Probably that the third is a hit is 0.05. Yeah, that's what we want. Not 0.036.
Hit final check and see what answer it spits out.
This is exactly how, whoops. This is exactly what we'll do on the exam. Don't worry about that homework question. It's going to mark you wrong. I won't take it off your homework grade. Don't worry about it. I'll ignore it. So I'm going to leave what I have. I'm not going to do their big crazy method. I'll have to check on it later. But yeah, let's just leave it at that. Does that make sense? So we will stay with this method. We'll just stay with this. One over. Okay. Teacher found the probability that a student studies for a test is 0.6. And the probability that the student gets a good grade on a test is 0.5. And the probability that both occur is 0.38. Are these events independent? Now, remember what I said earlier. I've said a lot of things today. For independent, what they're wanting you to figure out is independent means, well, you guys are just thinking, hey, I know studying is obviously not independent from good grades. And you're, of course, right. Then that's true. But they want me to do like an official math test, meaning this way. Independent, remember we said if A and B are independent, if the probability of A overlap B is the probability of A times the probability of B. Remember that? That was the test I gave you maybe 30 minutes ago. So they're basically saying, look. We're giving you the probability that both occur, 0.38, that's here, A and B, and both, right? And that 0.6 is A, and 0.5 is B. Are these equal? No, this is 0.30. No. And so you're right, they're not independent. Of course, you already knew that. Seems kind of silly. You already knew that studying has a relationship to grades. But they're just having me formally show that with the math there. So they're not independent. All right, we good with that? Does that make sense? So for that number 19, we'll just leave number 19 with my. That's a good one. Remember graphing and that whole graphing thing. Let's start going so we can finish the practice exam next time. All right, so remember these. It's been a little while. Linear programming. And I will give you one, my real exam is just like my practice exam. I will give you one, just like this, where you have to actually show me a graph. You can use your graphing calculator, though. Totally use your graphing calculator to help. Remember how we did these on the graphing calculator? You got to solve both these equations for y. Get y alone and then type in your graphing calculator. You guys have that with you? Let's try that. So I'll take this one, and we'll go, okay, so 2x plus 6y greater than or equal to 30. So solve for y. So that means I'm going to grab that 2x and jump it over. Remember when something jumps to the other side, it becomes a negative, like that, negative 2x. I just subtracted 2x from both sides. Really? And then divide by 6. That. And so you could go ahead and type that into your graphing calculator if you want. Be a good idea. Put in y1 is minus 1 divided by 3x plus 5. If you have the graphing calculator. And then let's do the other one here. 4x plus 2y greater than or equal to 20. Jump the 4x to the other side. Get to there. Divide through by 2. Minus 2x plus 10. So that would be y2. So far, so good. Am I racing ahead of you? So remember how to do these graphing ones. Just solve for y in both equations. Type in y1, y2. Hit the graph. You can see how big to make your window, huh? Negative 10, positive 10, negative 10, positive 10. Just do that with the x min, x max, y min, y max. Hit the graph button. I'll do a rough graph of what you'll get. Let me see. So the first one, the red one, will be, let's see up here, 5. I can just do it by hand. It's up at 5. 1, 2, 3, 4, 5. It's kind of small. Right there, and then down 1 over 3, like that. Down 1 over 3. And down 1 over 1, 2, 3. And down 1 over 1, 2, 3. Yeah, so it's sort of headed down like this. The red one. And then the black one starts up at 10 and goes down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. There's the black one. So you should get something like that. Is that what you're getting on the graphing calculators if you graph those? Okay. And now x and y greater than 0. They always put that. That means what? That means we're only dealing with the first quadrant, huh? Because that's where x and y are both positive. I don't even care about these other 3 quadrants. That's usually what we do. We're just dealing with positive x's, positive y's, first quadrant.
Do you need us to show that on the test?
Nah, I don't care at all. You can do nothing about that. That's fine. And then Now, which way does the shading go? Does the shading go like above the lines or below the lines? It's either going to be below both lines, which would be in here, or above both lines, which is out here. Which one is it? How do you know?
Above because it's greater than.
Above because it's greater. Yeah, see how they say greater? Greater is always above, huh? On that, right? Greater, greater, even from the beginning, you know, greater, greater. So greater is above, totally right. So that means its shading is out here, above both lines, huh? See how that works? If it had said less, then it would have been in here, huh? For the less, it would have been below both lines, it would have been in there. Okay, so greater is above, it's all the shading up there like that. Now, what do we do next?
Intersection.
Yeah, good. You got to find the corners of that shaded region. Can you see what I mean by the shaded? It goes here and here, doesn't it? So this is a corner where it hits the axis. This one and wherever that one is. We got to find those three edges on the jagged points of the shaded regions. Those three dots. The two places it hits the axes, and then the one in the middle. We've got to find the coordinates of those three dots. Now, how do you do that? You can do it on your graphing calculator pretty nicely. Let me erase this and I'll jump in there to show you that. Okay. So, yeah, what you can do is to find, first off, to find the point in the middle, this point, you do the intersect, right? Remember, after doing graph, you hit second, calc on the TI anyway, and you choose intersect. And I think you can just hit enter, enter, enter 3 times.
4.
What is it?
3, 4.
Thank you. So it's 3, 4. Guys getting that? X is 3, Y is 4. So we'll get that point. Now, to find the other 2 points, we got to be a little more tricky. To find, there's different ways to do it. You could, to find, say, this one. It basically, you can look at the table. Remember how we hit second table? Isn't the table above the graph button or something? Second table. And just look in the table, because remember, this one is over 0 up something, and this one is over something up 0. Over something up 0. You know what I mean? So in the table, you find the XY table, you'll have a Y1 and a Y2. Basically, you're looking for, first off, what's next to 0. What are the 2 numbers you have next to 0 there?
10 something else.
Yeah, maybe I can tell also.
5 and 10.
5 and 10, yeah, so let me see, I did Y1 in what? Was Y1 my black one? Or my red one was first, huh? So yeah, so it's X is 0, 5. Yeah, 0, 5. So Y1 is 5. And Y2 should be 10, yeah. So yeah, can you tell which, so first off, when you see 0, 5, 10 in your table function, how do you know which one this is? Well, the lower one is there, the higher one is there. This must be the 10. Do you see that? See how there's 2 places it hits this axis when you're over 0 up this amount and that amount? See those 2? The higher one is the 10. So that must be, the 10 must be this one up here, huh? Right? Good? Now, and then for this one, you look for where one of the Y values is 0, don't you? It's actually going to be a 0 in Y1. Because that was this was my Y1 line. So what do you have for X next to Y10?
10,
Is it 10?
15.
going in at 15, sorry.
That's 15, huh? 15? Yeah, it's 15. Getting that. There is another one for this 0. That one's 10, huh? So that means this one's over 10. Wait, is that right?
It's 5.
Yeah, that one's 5, huh? I'm getting confused. Why did I think that was? No. Wait, do I have the zeros in the wrong spots?
I think it's fine. Yeah, it's fine.
And does the 5 though go with the 0 in the middle? Instead? Go that backwards? No? It's right? Okay.
It's fine.
Anyway, one of them is clearly over 5, and one of them is over 15. We want the 15 because that's the one that's further over. Yeah. So you guys getting those off the table? See how to find those?
Where
Yeah.
are we plugging those zeros into?
Oh, so I'm not plugging them in. I'm just looking at the table feature.
Oh, you're just looking.
Yeah, just looking. So I don't know on the Casio.
No, I got that.
You got that? Okay, yeah. I'm just looking, just the table, just examining the table in the memory banks
Okay.
and just seeing those. Yeah. Make sense on that, on the TIs anyway? You can get those in the Casio some other way? Okay, good deal. So, okay, so we got those 3 points. Now, what's the final thing we do to answer the final part of the question?
Plug them in.
Yeah, plug them into that Z, right? So now we go, all right, I'm gonna erase all this so you got that down. Plug them into the Z. We say, okay, we're trying to minimize, and what are we trying to minimize? Z equals 0.18x plus 0.12y. So we do them one at a time. We do the 0, 10. We do the 3, 4. And we do the 15, 0. And we just plug them in. So 0, 10, put in 0.18 times 0, 0.12 times 10. What is that, 12? No, 1.2? 1.2 for that one. The next one, we plug in 0.18 times 3 plus 0.12 times 4. Somebody got that number? The last one's 0.18 times 15 plus 0.12 times 0. Somebody got those?
1.02.
For the second one?
Yeah.
Thank you. And the third one is, what's that, 180 and 2.7? Or am I doing that right?
Yeah.
2.7? Is that right? Anybody get that other middle one? Is that
Yeah.
good? All right, so then which one do we want? We want minimum, the lowest. Who's the lowest? I guess this one, huh? 1.02 is a little bit lower than 1.2, right? Dollar and 2 cents is less than $1.20. Huh, and certainly less than 270. So the minimum is here. This is the answer. The 3, 4. X is 3, Y is 4 is the minimum answer on that one.
So on this, are you looking then for the minimum and the graph? Are those the two things?
Yeah, you have to actually use the graphical method. Yeah, you got to show me the graph and show me the minimum. Yeah, everything we just did. Well, that was just one of the questions. We'll do more on Tuesday. We'll do the rest of the practice exam. So the only thing that's due is the last section we just finished. 8.5 is due on Tuesday, and we're done with the material for the exam next Thursday. Next Thursday, we take exam 3. We'll finish reviewing on Tuesday. Have a good weekend, guys.